So what can we do to help us solve the non-homogeneous system where it's vector x prime plus matrix A times vector x plus some other vector f? See, it's not a homogeneous system now. What can we do for that? So let's investigate that.
Okay.
Alright, so here we go. A particular solution, xp, is a vector free of arbitrary parameters. In other words, there's no non-specified constants, whose entries are functions that satisfy this system of equations. So that's interesting, I hope you think. So let's get into this.
Oh yeah.
Okay, so the general solution of a non-homogeneous system, if we have an xp, vector xp, a particular solution of the system, x prime equals vector or matrix A times vector x plus f on an interval I, and let xc be the solution of the homogeneous system that doesn't have that f attached on the same interval I, then the general solution to this system is our xc, that's this big thing, right, plus our xp, the particular solution. So it's similar to what we did in solving non-homogeneous equations. So do you see the similarity?
No.
You don't? Well, but I mean, when we solved equations in Unit 3, we often wanted to find the solution of the homogeneous solution, the homogeneous system, and then find a particular solution. Sometimes we use undetermined coefficients, sometimes we use variation of parameters. That was actually the hardest part of those usually, don't you think?
No.
Well, I sort of thought it was, but anyway, that's what we have to do. And so it's very similar to what we did in that circumstance. So I hope you don't mind if we do an example.
No.
Okay, so we will do that. So here's an example. Verify that the vector xp is a particular solution of this system, and this is a monster-sized system. X prime is matrix 1, 2, 3, negative 4, 2, 0, negative 6, 1, 0 times vector x plus, now this is an interesting way of writing this, but this is the vector of constants, negative 1 and 4 and 3 times sine of 3t. In other words, this is negative sine of 3t, this is 4 sine of 3t, and this is 3 sine of 3t, because this is just a constant multiplier. And so let's see if xp is a solution where xp is this 3 by 1 vector, sine of 3t, 0, and cosine of 3t. So that's what we got to check.
Okay.
Alright, we will do it. So, start by finding what is x prime of p equal to, and that would be the derivative of this is 3 times the cosine of 3t. The derivative of 0 is still 0, and the derivative of cosine of 3t is negative 3 times the sine of 3t. So we know what x prime, or xp prime is. Now we also want to see what the matrix times this xp is equal to, and then we also want to add that to our f vector. So let's see what that turns out to be. So if you multiply this out, you get, let me see, sine of 3t, 0, and 3 cosine of 3t. That's this piece. And then negative 4 times sine of 3t, this times 0, this times 0, so negative 4 sine of 3t in the middle. And negative 6 times sine of 3t, 0 here and a 0 there. So negative 6 times sine of 3t in the third slot. And we're going to add that to this this vector here. That's what's here. So that's our f. And let's see what happens when we add that. We'd have sine of 3t minus sine of 3t plus 3 cosine of 3t, so that's just 3 cosine of 3t. In the middle, we're going to have negative 4 sine of 3t and then plus 4 sine of 3t, so we get 0. And then here we got negative 6 sine of 3t plus 3 times the sine of 3t, so that would give us negative 3 times the sine of 3t, and look at that. That's exactly what we got when we found the derivative. So we did verify that that is a particular solution. So, we ready to move on to the next lesson?
Okay.
Okay, we'll move on to the next lesson.
Okay.
All right, everyone's ready.
Okay.
Okay, we are going to move on to the next lesson now.